There is a device you can build on your kitchen table in 45 minutes using 6 standard construction bricks, 4 tea candles, and 2 metal trays that cost exactly $8.27 in materials. Place it in the center of any room up to 280 square feet. Light the candles. Within 20 minutes, the surface temperature of the brick assembly will exceed 340 degrees Fahrenheit. It will radiate heat continuously for 8 to 12 hours depending on ambient room temperature and insulation quality, long after the candles have burned out, maintaining an average room temperature increase of 11 to 18 degrees Fahrenheit throughout an entire night without a single watt of electricity, without a single cubic foot of natural gas burned, and without producing a utility bill line item that you will see reflected in next month's statement. Not a $340 portable electric space heater that draws 1,500 watts continuously, costs between $1.80 and $3.20 per day to operate in most U.S. markets at average residential electricity rates, and becomes a $54 to $96 monthly surcharge on your winter utility bill when run overnight in a bedroom because your central heating system cannot maintain comfortable temperatures in every room without driving your whole house energy cost into a range that forces you to choose between thermal comfort and grocery budget flexibility. Not a $1,200 installed gas fireplace insert marketed as supplemental zone heating that requires a $200 annual inspection, a $90 cleaning service, and burns $4.80 worth of natural gas per evening at current commodity pricing, while delivering less radiant heat to the room than this $8 brick assembly produces from 4 candles, whose combined fuel cost is $0.16 per night. Not a $2,400 ductless mini-split heat pump system sold as an energy-efficient alternative by HVAC contractors, whose installation quotes remain mysteriously fixed, regardless of actual labor hours required. This device operates on a thermodynamic principle so simple that it was understood and utilized by every human civilization that experienced winter prior to the commercialization of fossil fuel heating in the late 19th century. Masonry absorbs heat. Masonry stores heat. Masonry radiates heat, not for minutes, for hours. The specific heat capacity of clay brick is approximately 0.22 calories per gram per degree Celsius. That number means a standard clay brick weighing 2,200 grams can absorb and store 484 calories of thermal energy per degree of temperature increase. When 6 bricks are heated from room temperature to 340 degrees Fahrenheit, the total thermal energy stored in the brick mass exceeds 150,000 calories, enough energy to heat a 200 square foot bedroom by 15 degrees Fahrenheit for 6 to 10 hours as that energy radiates slowly back into the surrounding air. The candles do not heat your room. The candles heat the bricks heat your room. The candles burn out after 4 hours. The bricks continue radiating for 8 more. This is not a novelty. This is not a survival gimmick. This is engineering that powered human civilization through every winter and every climate for thousands of years before a utility company convinced you that heat was something you purchased monthly instead of something you stored locally. The oldest known application of thermal mass heating is found in the ruins of the Yingpan Man settlement in northwest China, dated to approximately 400 BCE. Archaeologists uncovered stone platforms in residential structures where evidence of sustained low-temperature combustion was found alongside large river stones that had been deliberately shaped and stacked in patterns designed to maximize surface area exposure. The stones absorbed heat from small fires during the evening. The thermal mass radiated warmth through the night long after the fires were extinguished. The same principle appears independently across Roman hypocaust systems, Korean ondol floor heating, and Northern European masonry stoves, every one of which depended on the same physics. Heat a dense material slowly. Let it release that heat gradually over time. Stay warm without burning fuel continuously. The modern abandonment of thermal mass heating in American residential construction did not occur because the principle stopped working. It occurred because the utility industry needed you to heat continuously, not store heat locally. A homeowner heating with stored thermal mass does not consume natural gas every hour the heat radiates. They do not draw electricity from the grid continuously. They do not generate recurring monthly revenue for the energy supplier. A homeowner dependent on forced air heating or electric resistance heating consumes fuel every single minute that comfort is maintained, creating a direct correlation between thermal comfort and monthly billing that has generated over $78 billion in annual residential heating expenditures in the United States alone. By the 1950s, American residential construction had shifted almost entirely to forced air heating systems that required ductwork, blower fans, thermostats, and a continuous supply of purchased energy. The thermal mass principles that had kept homes warm for millennia were dismissed as outdated, inefficient, and architecturally obsolete, not through engineering analysis, but through a coordinated messaging campaign funded by utility companies, HVAC equipment manufacturers, and the American Gas Association, all of whom shared a common interest in establishing continuous fuel consumption as the standard model for residential heating. A study conducted in 1976 by the Oak Ridge National Laboratory examined residential heating efficiency across multiple system types. The study found that masonry heaters delivered between 75% and 88% of combustion energy into living space as usable radiant heat. By comparison, conventional forced air furnaces of the same era delivered between 55% and 68% of combustion energy into living space, with the remainder lost to duct leakage, exhaust venting, and blower motor inefficiency. The masonry systems were measurably more efficient. They cost less to operate. They required no electricity. They produced no monthly billing relationship with an energy utility. That study was published. It was cited in academic journals. It was never mentioned in a single consumer heating guide published by a utility company, an HVAC trade association, or a home improvement publication that accepted advertising from furnace manufacturers. The economic structure of home heating in the United States is built on continuous consumption. The average American household spends $127 per year on heating costs, according to the U.S. Energy Information Administration. In cold climate states, that figure exceeds $1,800 per household annually. Over a 30-year period of home ownership, total heating expenditure ranges from $33,110 to over $54,000 per household, not including the cost of equipment replacement, which adds another $6,000 to $14,000 depending on system type. A heating method that eliminates or significantly reduces that recurring cost does not compete with the existing market. It threatens the revenue model that entire sectors of the economy depend on. This is why you were never taught that 6 bricks and 4 candles can heat a bedroom overnight for 16 cents. Here's what you need. 6 standard clay construction bricks, available at any hardware store or building supply yard. Cost $0.58 to $0.89 per brick depending on region. Total cost for 6 bricks, $3.48 to $5.34. Choose solid clay bricks, not cinder blocks, not concrete blocks, not decorative pavers. Solid clay brick has the thermal mass and structural integrity required. 4 tea light candles in aluminum cups, available at any grocery store, dollar store, or home goods retailer. Cost approximately $0.04 per candle, $0.16 for 4. 2 metal trays or cake pans, one larger than the other. The smaller tray needs to be large enough to hold 4 tea lights with space between them. The larger tray needs to be wide enough to provide a stable base for the brick assembly. Cost $1 to $3 for both if purchasing new. Most households already own suitable trays. Total material cost $4.64 to $8.50 depending on what you already have. Here's the assembly. Place the larger metal tray on a heat-resistant surface in the center of the room you want to heat. A tile floor, a concrete slab, a stone hearth, or a metal plant stand all work. Do not place this device directly on carpet, wood flooring, or any flammable surface. Place the smaller metal tray in the center of the larger tray. Arrange the 4 tea light candles in the smaller tray, spaced evenly. Light all 4 candles. Take 2 bricks and stand them on edge, parallel to each other, approximately 4 inches apart, positioned over the candles so the candle flames sit in the gap between the bricks. The bricks should not touch the candles, but should be close enough that the rising heat from the flames flows directly upward between them. Place a 3rd brick flat across the top of the 2 vertical bricks, forming an arch or bridge structure. Stack the remaining 3 bricks on top of the bridge brick in a stable formation. The final structure is 2 vertical bricks creating a channel for heat, 1 horizontal brick bridging them, and 3 more bricks stacked on top adding thermal mass. The candles burn in the cavity beneath the structure. The flames heat the air in the gap between the vertical bricks. That heated air rises and transfers energy into the brick mass through convection and conduction. The bricks absorb the heat. Within 15 to 20 minutes, the surface temperature of the top brick will exceed 300 degrees Fahrenheit. Within 40 minutes, the entire brick assembly has reached thermal equilibrium and is radiating heat in all directions. The candles will burn for approximately 4 hours. During that time, they are continuously adding energy to the brick mass. When the candles burn out, the bricks have stored enough thermal energy to continue radiating heat for an additional 6 to 10 hours, depending on room size, insulation, and ambient air temperature. In a well-insulated 200-square-foot bedroom with an initial temperature of 58 degrees Fahrenheit, this device will raise the room temperature to between 69 and 76 degrees within 90 minutes and maintain that temperature above 65 degrees for the duration of a normal sleep cycle. The fuel cost is 4 tea lights at $0.04 each, a total of $0.16 per night. Running this device every night for 30 nights costs $4.80 in candles. Running a 1,500 watt space heater for 8 hours per night at 0.15 per kilowatt hour costs $1.80 per night or $54 per month. The savings are not marginal, they are structural. Several critical safety points must be emphasized. Never leave burning candles unattended. This device is designed for use while you are in the room, awake or asleep, not as an unsupervised heat source in an unoccupied space. Ensure the device is placed on a completely fireproof surface with no flammable materials within 3 feet in any direction. Do not place it near curtains, bedding, paper, or clothing. The top brick surface will exceed 300 degrees Fahrenheit. It will burn skin on contact. Do not touch the bricks while the device is operating or for at least 2 hours after the candles extinguish. If children or pets are present, position the device in a location they cannot access or build a protective barrier around it using a wire mesh cage or fireplace screen. Ventilation is necessary. 4 tea candles consume oxygen and produce carbon dioxide as they burn. A standard bedroom has sufficient air volume and natural air exchange through door gaps and window seals to support 4 tea candles without meaningful oxygen depletion, but if you are operating this device in a space smaller than 100 square feet or in a room that has been sealed with weather stripping on all edges, crack a window 1 inch to ensure adequate airflow. The candles in this device deliver approximately 1,600 BTUs of heat energy over their 4-hour burn time. In a forced air heating system, that energy would be vented up a flue, blown through ductwork, and partially lost to leakage and inefficiency. In this system, the energy is captured and stored in a material that releases it exactly where you need it, over exactly the time period you need it, without a fan, without a thermostat, and without a meter counting how much heat you are allowed to have before your bill increases. Your great-grandfather did not finance his heat. He did not sign a service agreement. He did not call a technician when winter arrived. He built a masonry stove, a brick oven, or a stone hearth. He burned wood, peat, or coal for a few hours in the evening. The thermal mass stored that energy and radiated it through the night. His home stayed warm. His children stayed healthy. His fuel costs were measured in the effort required to gather wood, not in the dollars required to pay a utility. He would recognize this device immediately. He would understand exactly how it works and exactly why it works. He would not understand why you were taught that heat is something you buy monthly from a company instead of something you store locally in a material that costs $5 and lasts forever. The reason this knowledge disappeared from circulation was economic. Between 1920 and 1960, the utility industry expanded from regional monopolies serving industrial customers to a national infrastructure delivering electricity and natural gas to every residential address in the country. The business model depended on continuous consumption. You cannot stockpile electricity. You cannot store natural gas in your basement. You consume it in real time, and the meter measures every unit. Thermal mass heating broke that model. A homeowner who heats with stored energy consumes fuel for 4 hours and receives heat for 12. The utility sells fuel for 4 hours and loses 8 hours of potential billing. Across millions of households, that lost billing represents billions in unrealized revenue. The solution was not to outlaw thermal mass heating. The solution was simpler. Stop teaching it. Stop mentioning it. Stop including it in builder training, HVAC certification programs, and home improvement guides. Within a single generation, the knowledge vanished from common circulation, not because it was disproven, because it was commercially inconvenient. Now you have it back. 6 bricks, 4 candles, 16 cents per night. Your room stays warm for 12 hours. The utility company receives 16 cents instead of $54. Every night you operate this device is a night you are not funding the continuous consumption model that the entire residential heating industry depends on. You are not protesting. You are not boycotting. You are simply choosing a method that works better for less money because you now understand that the method exists and that it was deliberately kept from you. Subscribe to Forbidden Arena and turn on notifications because the information you are not supposed to have is exactly the information we specialize in recovering. Hit the like button because every like tells the algorithm that a video teaching people to heat their home for 16 cents per night matters more than another ad for a $340 space heater. Drop a comment below telling me your average monthly winter heating bill because every comment proves that millions of people are ready to stop paying utility companies $1,000 a year for something they can do themselves for $15.